Go ahead and get started. Miss Moore, can you see my computer? So I'm at my desktop.
I can.
Okay, good. All right. Let's do the transparency. Pull up the. Okay, now that we're officially started, let the text come in now. There's the first one. Yep. I can tell the future. I don't know. I wish I knew. Let me go back and add her. Okay, there's number 1 out of 10, or number 2 out of 10. There's number 3.
Hello.
Hello. Really? You're just gonna text me just so okay, make me feel good. All right. No, it only works when I minimize the Skype screen. As soon as I minimize the Skype screen, that's when somebody texts me and says, I need to Skype in. I'll leave it on just so y'all won't think I'm crazy. Okay, first question, homework question we got. We got about 1,000 to go over, so as y'all can see. Which chapter are we in?
1,000, is that all?
Yeah.
Oh, that's good.
Chapter 4, right?
Yes.
4.1, 17/7. When I say 17, that's like in the book. If you got a book, if you turn to 4.1, number 17 in the book, it looks like that one. If you got your online homework printed out, then it looks like number 7. Notice I said it looks like. It is not the exact same. So, as we go to that, for those that are paying attention and not talking while I'm talking, looks like we've got a data set. So I'm going to go ahead and put this in my Excel spreadsheet. I don't have any idea what it's asking. I'm not looking at the directions right now. This is let me see again what it is. Let me read the directions. The following data, draw a scatter plot, compute the correlation coefficient, and come in at some type of relationship between X and Y. All right, this is basically a line problem, okay? So I'm going to take my handy dandy calculator. You've got points. I'm going to go ahead and take these points, and I'm going to go to data. No, insert. I'm not used to this Windows. And scatter plot. And there it is. That's what it looks like. Now, yeah, you go to hit that little button right here. Hit that little button right there. Now, another way you could do it is use your handy dandy calculator. Now, in this case, the calculator is best. Why? Well, I'm going to show you why. When you pull up the handy dandy calculator, and you pull up the question, and then the calculator again, you put in the data. So you go to Stat, turn it on first. Go to Stat, Edit, and 1, 5, 7, 7, 9. I'm sorry, what? Yeah. If you're going through it, but not trichromatic. 1.4. That's kind of like when you go into a store and you give them a 20 and they check it to see if it's counterfeit. If I was going to make counterfeit money, I wouldn't go to a convenience store, and I would be passing it off some other place. I wouldn't go to a convenience store and try to pass it off. Anyway, 2.0, or let's see, 2.1, 2.5, 2.4, and 3.0. Now, go to second stat plot, or y is equal. Hit enter. They want a scatter plot, which I think scatter plot is that first one.
And this one, after you put them in, just hit enter. After you put them in.
Hit second, y is equal, and hit enter on the first one, and hit on, enter, and then move over to stat plot, which is that one right there, and graph. Now you can hit zoom. I think it's statistic. Which one is statistic? 9. And there's your stat plot. And let's look at the Excel spreadsheet. And bring that in. So, do they look alike? Well, yeah. What you're looking at, look at these two together. Are these two together? Yep, they are. So, you've got the same type scatter plot. Now, what is a correlation? It's a line, right? So we're going to take our handy dandy line maker, and I'm going to make it red, and I'll make it blue since we've got blue dots. And I'm just going to put one right here, and I'm going to put one right there. Now, am I hitting all the dots? No. So technically I need to take this and erase it. And I need to kind of move it down a little bit. Like right about there. Alright. Now I'm still not touching every single one, but am I touching these two pretty good right here? Yes or no? Yes. So I can use those 2 points. Yeah, y'all just come on in whenever, that's fine. How was IHOP? Were the pancakes good? If you're going to be late, you might as well just go ahead and eat. Don't stop. No, you just woke up. Oh, that's even better. Okay. So you just sleep until 1 o'clock. Okay. Okay, that's good. You work third? Okay, well, you're excused. Do you work third too? Oh, you're a loser. Just kidding. You don't have to. You can Skype in. You know that, don't you? Okay. Now, let's see. What can I do if I have a line and I got 2 points on the line? What can I find? You can find your slope, Hubert. Yep, you can. Unless you just want to quit and discourage yourself, and then you can say, I don't know how to do the slope, I'm going to quit. Now, what I'm fixing to show you is how to do it by hand, but that's not what they're going to ask you for. They're going to ask you to calculate it with your calculator, and that's fine. I'm just showing you how to do it by hand. So I'm going to use this point and this point. Why am I using those 2 points? Because if I use this point, it takes it off of what? These 3 points right here. So I kind of drew the line to where it was going through these 2 points. It's touching that point. It's just barely below this one. So it's kind of like fitting the line in the best fit. When I do that, I touch these 2. So I'm going to use those 2. This one is, somebody tell me what the point is on this one. I got it covered up. 1 comma what? Somebody tell me what it is. 1 comma, huh? And this one is 5 comma what? 2.1. Which way do we read? Left to right. So this is x of 1, y of 1. This is x of 2, y of 2. That's your first set of x and y's. This is your second set. The slope is equal to delta y over delta x plug and chug. Before I plug anything in, I draw big little sets of parentheses. Some of y'all don't need this because y'all are smart enough. Well, I'm not smart enough because I still make mistakes. Those of you that don't make mistakes, you know, y'all walk on water anyway, so I still use parentheses. Everybody in here should be using parentheses. That's what I'm trying to tell you. You're not perfect. Okay? Somebody's still not using them, but that's okay. You'll get something wrong on the test, and I'll look at it and I'll say you didn't. You walk on water. Y sub 2 is 2.1. Y sub 1 is what? 1.4. X sub 2 is what? 5. And x sub 1 is what? I'm going to do the bottom for you. 4. Now okay, now this is real bad. This is some real heavy math. $2.10 minus $1.40. Oh my gosh, y'all are just amazing. But if I asked you what 2.1 minus 1.4 is, you'll put it in the calculator. Why is that? Now, 70 cents divided by 4. Well, 70 cents divided by 2 is 35 cents. And half of 35 cents is what? 17.5 cents. So that's what, 17.5? Somebody check me out. 0.175. Somebody help me out. 0.175. It's 0.17. It's 0.7. There's a point there. Thank you. That's my slope. And I write that down. M is equal to 0.175. Everybody got that? All right, now I'm going to pick a point. I'm going to pick 1 and 1.4. Why am I picking that point? KISS method. What's the KISS method? Exactly. Why would I go use 105 and 206 when I can use 1 and 1.4? So I'm going to pick that. That's my x of 1, y sub 1. I'm going to pick 1 and 1.4. That's my point. My slope is equal to 0.175. So if I've got a point and a slope, what am I going to use? Point slope equation, Hubert. Y minus y sub 1 is equal to m into x minus x sub 1. Y minus parentheses is equal to parentheses times x minus parentheses. Now I'm going to erase this down here so we keep going. Now plug and chug. I love it when I say plug and chug and people go, what do I plug in? What are you giving? Somebody tell me what you're giving. X of 1, what? Y sub 1, and what is this? M. And that's why I put these parentheses here. Y minus parentheses, and what's y sub 1? Equals, what's m? 0.175. And what's x of 1? Is that 1? Okay. All right, now solve it for y. I'll do the next step for you. Y minus 1.4 is equal to 0.175 times x minus 1. Now finish it. You gotta get y by itself. This is on. Well, just shut down. Whoever said that, just shut down and just don't do it. That's the best thing to do. Throw your pencil down too. Make sure it pops. You don't know how to do that, right? Throw it where the pencil makes a pop on the pencil. You don't know how to do that? I'm a professional at it. Y equals 0.175 x, because you got to do what with this 0.175? Distributed, Hubert. That's right, class. Minus 0.175. And then what do we do with this negative 1.4? Bring it across the river and it becomes what? So y is equal to 0.175x. What's 18 cents? You owe somebody 18 cents, you got $1.40. After you pay them off, you still got $1.22. Somebody check me. Or $1.21 or $1.215. Whatever y'all come up with, it's about the same. Now what is this? This is the equation for this line, this blue line that I just made. Y is equal to 0.175 x plus 1.22. Now, why is this important? Well, if you're in business, marketing, business management, if you're trying to predict something, how many people you think are going to be dead on the floor in this 10th year or whatever they represent, then you can take this number right here, which is x, and plug it in right here. And move that over, that's 1.75 plus 1.22, and that comes out to be $1.75 plus $1.22 has come out to be 2.97, which would be what? Right there. So you can predict what's going to happen as long as you got that formula. Okay? Now, is this correct? No. All right. This is by hand. I want everybody to put a note around here. This is by hand. You're not going to be able to do this problem by hand. But why am I showing it to you? To bring back how to do it. All right. I'll take an answer by hand. If you don't know how to work the calculator, then do it by hand. I'll give you at least half credit. All right. But I'm going to show you how to do it on the calculator. Why can't you? Well, you can do it by hand, but it just takes about a half page of work. All right. You have to use least square regression, and I don't teach that because that's just your calculator does it, and I'm not going to teach you to do it. All right, because it's just tedious work. All right. So what the computer does, or the calculator does, is it puts a line from here, and it puts it exactly at the best point right in here somewhere, and it finds a point, say like right here. I'm going to paint it. I'm going to paint it blue. And it puts a point right there. And it uses that point instead of we use this point. It uses that calculated point, and it gets an exact number here and an exact number here. So whatever we get is going to be more exact than my by hand equation. All right? So how do you do that? Well, you go over here to your calculator, and you pull up your handy dandy stat. All right, turn it all back on again. and you go to stat, and you go to calculate, first variable statistic, no, linear regression. Write that down, number 4, linear regression. And you hit enter, and it goes automatically to L1. You don't want to go to L1, you want to go to L2, okay, because that's the actual data points. Or, I don't know, I haven't used this in a while, so I'm going to hit second L1, comma, L2. I don't know if it's going to take those or not. Yeah, it did. Look at there. Now, how far am I off? 0.19 against point what? 1.8. 1.2 against 1.22. So I'm not off by what? Very much. Why? Because I'm perfect like that. No, the reason I'm close is because I dropped down below this point to hit these 3 points instead of just hitting this point. That's why. Now, if I moved it up just a little bit, I probably would have got it even closer, but I didn't. I just used this point right here. You see what I'm saying? Mm-hmm. So you can use a point on the graph and do it by hand and still be close. But it's not going to be as close as the calculator can get it. All right? So that's how you use the calculator. Now, why don't they call A, M? Don't ask me. I don't know why they won't do that. But M is 1.19, and your 1.22 is 1.16. All right? So the calculated version, I'll put it in red. Your handheld version versus your calculated version is 0.192 plus 1.16. And you're really talking about 0.18, 19, and 1.2 and 1.2. So you're not far off. We'll do another one of these. Now, I have no idea what the question's going to ask, but I think we've got enough information to know. So let me go back to the question. All right, which one does it look like? Well, you're looking for those 2 points that are close together. I think it's right here, isn't it? Yeah, there it is. There's the 2 points that are close together. See there? Why isn't it these? Well, this one's going left to right up. This one's going left to right up. So it's not these two, because these two are going which way? Left to right, they're left to right down. So it's not these two. So it's one of these two. So you pick that one. Compute the correlation coefficient. Well, there is a way you can compute the correlation coefficient on your calculator. Hold on, let me find it. I didn't know it was going to ask that. Correlation coefficient is how much correlation do you have? 0 is hardly any. Negative is negative correlation, and close to 1 or over 1 is positive correlation. I think it's on stat.
How are you, Rob?
Calculate. I think it's first variable statistic. No, it's not on that. I think it's on linear regression, only this one doesn't put it on. I think on y'all's calculator, on newer calculators, I think it puts the correlation coefficient, but y'all gonna have to look. Hold on a second. Some of y'all have more information down here. I don't know how to get it on this one. So does anybody have more information on this other than Y, A, and B? Huh? Okay, let me look it up right quick. Let me look in the book right quick and see if I can find it for you. No, it has it. Just hold on a second. Let me Let's see, what chapter is this, 4? And this is 4.1. There should be somewhere in here about a correlation coefficient on the calculator. I know the calculator does it. I just haven't done it in a while. No, you don't want to use the formula. It's too tedious. Take you forever to do it. There's the formula right there. Take you about a half page just to do one problem. Problem. But once I show you how to do the correlation coefficient on the calculator, you won't have to worry about it that much. Okay, it's not there, so I'll have to Google it. Because I don't see anything that shows technology. Nope. And I know this is top secret information. Y'all can't pull this up on the internet. Yeah, I'm the only one that can do it. Right.
Because I should go.
No, heaven forbid. There it is. Right there. Let's see. Find the correlation coefficient on the TI-83. I'm not going to put all that on there. Absolute value. Just give me a second. I'm just viewing it. What are we looking for? I think that's, remember where I told you it gives more information? She just so it is. There it is. There it is. See how it gives you more information? Diagnostic on. You need to turn that on. So go to your catalog. There's a button on there called catalog. Let's find it. Because again, that's top secret information. Let's see, catalog. Oh, somewhere. It's right over the 0. I thought it was top secret. Yeah.
They should put it on YouTube.
Yeah, they should. Diagnostic on. There it is. Hit enter. Diagnostic on. Good. Now go back and type. Go to stat. Calculate. First variable statistic. Second L1, comma, second L2. Bada book. Bada boom. I love that commercial. Oh, I did the wrong thing. I'm sorry. I suck. Damn Russians. Y'all know that, don't you? Stat. Calculate. Linear regression. There we go. Now it's bada book, bada boom. I got you a shirt. I still have the receipt. Boom. Right there. 0.99. So is there a correlation here? Yes. Yeah, barely. 0.99. All right. Who's got a question on that?
You just put that equation in your life.
Yeah. Yeah, that's why I'm showing you on the calculator. Catalog. Go back to catalog. Try to turn it on again. Make sure it's on. Second, catalog. And type in D. No, it's not going to go to D. You have to go down to D. Diagnostic on. And enter. And now stat, calculate linear regression ax plus b, second 1, comma, second 2. And what you do with that, for those that just now, waking up after you worked third all night, let me check to see if nobody's, okay. Usually we have 8 to 10 people Skyping in at 15 till 1. Not today, everybody's, I guess, passed out. So here, you type in the information, and this is what you would write on your test. You would write y is equal to 0.192x plus 1.16, and you write down the correlation coefficient is equal to 0.9906, whatever it says to round to. They might give you a point. They might say, what is the prediction for x is equal to 10? Or x is equal to 100? Well, you would plug it in. Y is equal, and I love it when students say, plug it in for what? Oh, I don't know. It says x is equal to 100. Maybe you might want to plug it in for what? X? Yeah. 0.192, January 30th, 100 plus 1.16. And what's the rule with multiplying by 100?
With the decimal.
Reach for the calculator because you can't do it. Y is equal to 19.2 plus 0.6. Bless you. Please. $19.20 plus $1.16 is $20 what? 36 cents.
Okay, so I don't remember all when we had the pairs like that, but if we had to find the point of x, y.
This is the x. And
No, I
this
mean, if
is
we
what?
weren't given that.
You have to. You have to be some
You
information.
tell them you just have 2 points.
Yeah, 2 points. You have x, you read from left to right. If they tell you the 2 points, you have to use it. If they don't tell you 2 points, then you put all the points in and you punch it out on the calculator. Okay? Does that make sense? They'll either give you 2 points and they'll say, here's the 2 points. And they'll put them on the point. But that's a totally different animal. You're talking about algebra there, where they give you 2 points and you find the slope. And the reason this is different, somebody tell me why this is different. You come in like 20 minutes late, so don't talk. Don't say. Okay? What's the difference here? Don't try. What's the difference? What's the difference in this question and an algebra question? Be quiet. Like I said, you don't need. What's the difference? With a algebra question, you'll get this. Yeah, I know. I try to do that. I try to amaze y'all with my use of technology. That's an algebra problem. Why? Because you're going from point to point. Everybody with me?
Yes.
Okay. What did you do in this case? You solved, you took the 2 points, you got the slope, you found the y-intercept, blah, blah, blah. That's not what we're dealing with here. What are we dealing with here? We're dealing with, okay, I'm going to start right here, and I'm going to add this. No, that ain't going to work. And they ain't going to put it, no, that ain't going to work. And that ain't going to work. And that ain't going to work. And you just, I'm going to quit. Okay? You got a totally different animal. You got a correlation where you got to fit the line where it needs to go. Now, you could sit here all day and you could try to fit it, or you could just plug it in, punch it to the calculator, and it'll tell you where to put it. Okay? Now, how will it tell you where to put it? Well, let's pick a point. because you've asked a very important question. What's the difference in the two animals? Well, here's the difference. As I showed you, the first one, you've got the points. In this one, we've got y is equal to, what was it? Tell me what it was. 0.192 x plus what? 1 point what? 16. All right. Now, let's say that I want to draw this line. Okay? I'm going to pick a point at 0, or not at 0. I'm going to pick a point at 0. And it'll give me, it'll give me that point, and then I'm going to pick a point at 10, it'll give me that point. All right? So let's do it. Y is equal to 0.192 times 0. I'll do that for you because that's some hard math right there. Plus 1.16. Y is equal to 1.16. So 1.16 is right there. Now I'm going to blow this up in just a minute. We're going to draw it. And then Y is equal to 0.192 times 10 plus 1.16. And that's going to be Y is equal to 1.92 plus 1.16. And that's going to be Y is equal to $1.92. Be what? $3.08? Somebody help me out. 3.08. Okay, so that's that one. What I'm going to do is I'm going to take my Is that it? Okay? And I'm not going to try to draw a point on the blue. I'm going to plot these points. So I'm going to take my handy dandy red dots, and right here I'm going to put 1.16. Well, that's 1.5. So 1, 2, 3, 4, 5. That's a so right in there somewhere. Right with me? And then my other point at 10 is at 3.08, which is right about there. Now I'm going to take my red line maker here. And that's not what I wanted to do. I'm trying to stay in the chair so I can see. Hold on a second. Now, do you see why you have to do the equation? Because there's no way you would have put this line below this point right here. Why? Because what's the natural tendency for you to do if you're given 5 points? What are you going to put your pencil? You're going to put your pencil on this line right here like I did, and you're going to try to fit it in between these points. You see what I'm saying? But that's not the way to do it. The way to do it is to take the formula, the equation that you come up with, the calculator comes up with, and then plot your first point down there on a solid x value, and plot your point here on a solid x value, and then draw the line, and now you've got the perfect line that goes between those points. And notice, yes, it is above these 3 points, but it's also below what? This point and this point. So that is the line of correlation in this regression. This is it. That's the line. Now you don't have to draw that line. I'm just showing you what you've got, what you've produced. It's kind of like putting a round peg in a what? Square hole. You don't know where the line is, but when you get through with the problem, you can plot it. See? And now you can predict If you don't produce 0 widgets, you still have a cost of $1.16. Where if you produce 10 widgets, you'll have a cost of what? $3.08. Whatever the case may be, whether it's widgets, whether it's bodies, whether it's votes, whether it's whatever you're talking about. You can predict it at values that there is not. In other words, what is the word extraction? When you hear the word extraction, what do you think of? A tooth being removed, right? That's the first thing you think of, unless you're odd and you think of taking the LEM out of the rocket capsule in Apollo 13. Then you're just weird, all right? But most of the time when you think of extraction, you hear the word extraction, you think yanking a tooth out, all right? Well, what have you done with this problem? You've extracted the perfect line from the information given. That's what you've done. And that pays off. To have that information in here, that pays off. To be able to look at points and to be able to extrapolate or extract information out to where you don't look stupid in a what? In a meeting. It kind of helps. Okay? Because you don't want to look stupid in a meeting, especially when you're getting paid to be there. Right, Mr. Goolsby? You don't want to look stupid. Okay?
You get used to it.
All right. I can't believe you just did that. Oh yeah, you get used to it. I do it all the time.
Yeah, it's not that bad.
They just make fun of you the first few meetings. Then they don't pay any attention because you're an idiot, right? That's what usually happens. Yeah. All right, let's try nerding. And yeah, I spent a little bit of extra time on that one because I think it's important that you understand what you're actually doing. What'd you say? Yeah. Let me punch. What is ours come out to be? 0.9 what? 0.991? Well, it says round to 3. Pay attention. Look there. I don't have to put too much makeup on. And what is our correlation doing? It's increasing. I don't know if, okay, it's close to 1. And it has a what? And you feel good about yourself. No smokestacks needed on this pickup truck, right? All right, let's do a nerd. Now that we spent half the class on that one, but it was worth it. Y'all learned something, didn't you? Okay. Somebody's not, they don't pay attention. They don't care. They just want to disrupt class. I'm kidding. Now they can talk to me. All right. Oh, God, look. What a surprise. I think it's going to be so funny when eventually people are going to start using email in their classrooms, you know, by the year 3000 at Tri-County Tech. And, you know, when that happens, IT is going to be bombarded with, why do y'all cut the logout time so short? I just wish I could be there, but I'll be dead by the time some of the Tri-County Tech faculty start using email in their classroom.
So we need to put a time capsule out there, and that
Yeah.
can be your thing.
Yeah, if y'all would, when I die and y'all's grandkids, pass this on to your grandkids. I appreciate it. All right, so let's get back to where we were. Where were we? 120? Okay, that's the first question. But we covered 2 questions. Does that help you? You want to go over again, or you good? All right, let's go to 19. 19/8. Correlation coefficient. I'm going to let y'all do this one. And if you can't, then just consider yourself what? A failure. Well, I don't know. You got to look at the data set. Here's the data. Here's the data set. You got this. You sure? Okay, they're thinking what they're doing right here. This is a table for if you don't have a calculator, but I don't teach that. I just teach you to use a calculator. So But since n is equal to what? Let's see. 1, 2, 3, 4, 5. Probably going to be 0.878. Use your calculator. L1 means the first column. L2 is the second column. So yeah. It's kind of like when you learn how to use a chainsaw, you cut down a tree then. Yeah, that works really well. You pull it on top of your truck. Kind of like the guy that wanted to knock down a silo with a bulldozer. Y'all seen that video, haven't you? Okay, well, we'll pull it up. Let's pull up the DA that wants to push down a silo with a bulldozer. Does it matter?
It's one of those old ones, isn't it?
It's kind of, yeah, but it's still stupid. But you got people out there that's like it, that create and have driver's licenses. Okay, somebody's in their car. That's good.
Man, they're gonna do something very embarrassing, I can tell you.
Yeah, they're gonna fall down.
Somebody might say something that's like, "What do you think you're drug dealer?"
Yeah, exactly. Hey man, give me that cocaine, man. Okay. Yeah, we didn't agree on this price. Okay. 911. Yeah, one of my students just had a drug deal go bad. Now they're barely breathing in the microphone. Bulldozer versus silo. There he is.
Oh yeah.
Yeah, let's push this down.
Oh, tree.
What an idiot.
Walter. Shh. Walter spends 99% of his time on YouTube. Now, the good thing about this is that bulldozers, I have two bulldozers, and both of them have a cage on them. And that cage is supposed to be built that if it turns over, it will save you from being crushed. So it pretty much keeps you from, I don't know what this cat's gonna do.
But the key is, could a brick fit through that?
Yeah, now that would hurt. That would be the only.
We're not making pushing silos.
Yeah. Now this.
This looks like it can't go right.
Okay. Now why they got a car parked here?
I guess that'll die.
Because that track hoe is not going to have a problem. Now the top may come back down. I think they just put that there just to, it's a POS, so I think they're just doing it to make a video out of it. That would be a yes. I think it had a flat front tire. Didn't it? Flat. Yeah, that's a, what do you call them things? Suzuki what? Samurai's tracker or something? Yeah, that's disposable car. Yeah.
With 3 cylinders.
So make sure when you do something like this, don't do it.
Be sure to video it.
Yeah, be sure to video it so people can make fun of you.
Apparently multiple people have done this.
Yeah. We have one. It's 70 feet tall. It looks like one of those right there.
Very nice.
Yeah. And if my father, if he was still alive and told me to go out there and push down with it, I would not. because I got better sense.
You know a lot better luck pulling it out of it, I would think.
Yeah, you wouldn't get hurt.
Yeah, that's some powers like that.
Yeah, you wouldn't get hurt. All right, here we go. So we take our handy dandy calculator and we go to Stat, Edit, and we go over here and type in 2, 6, 1, 7, 9. And we go over here and we type in 3, 2, 6, 9, 5. And go to plot, second stat plot on, L1 and L2 stat plot on graph, and zoom, what was it, zoom stat, what was it, zoom 4? Somebody help me out. 4? No. You'll need to write it down so we can quit asking. Zoom 9. There you go. And it looks like pretty much we're all over the place, doesn't it? So you got to find out which one. So you pretty much got all over the place. So it's not this one. It may be this one. Doesn't look like it because there's a gap right here. See that gap? That one don't have it. Looks like this one. And yeah, it is. I didn't know that. But anyway, that's what you're looking for, is this gap right here. Okay. So you go to your handy dandy stat, calculate linear regression, and L1, comma, L2. Right there in front of you. And there it is. Wow, look at that correlation coefficient, 0.2. That tells you that you only got a 20% correlation, or a 0.2 correlation. Now, if you wanted to write that in a formula, it would be y is equal to 0.15x plus 4.2. So therefore, at 0, you get 4.2. So 1, 2, 3, 4. And there's a point right there. And at 10, what's 1.5? That'd be 5.7. 1, 2, 3, 4, 5.7 be right in there. So your correlation line is right there. Which means you got a positive slope of 0.15, which means that there's hardly any correlation there at all. And the correlation coefficient is equal to 0.19, or whatever they ask you to round it to. Well, we'll get to it in just a second. That's that done. R is 0.19. What was it? 0.18 what? What? Okay, the correlation coefficient, is it positive or negative? Positive, because you put your car right here, it's going uphill. And the absolute value of the correlation is, the absolute value is what is the distance between that and 0, 0.188. That's what it's asking, in my opinion. Is greater than the critical value. Okay, they want you to look up the critical value. I don't even know. Okay, what is N? In this case, somebody add up, what's N? N is 3, 2, 6, 9. Okay, 9, 9 and 5, 9 and 6 is 15, that's 20, 22, 25. 25 is 0.396, so it's less than, not greater than the critical value for this data set. I don't know what they want here, I guess, 0.396? And positive linear relation exists. I have no idea what the rest of it asks for. I guess that's it.
Oh,
Golly, how did I get something wrong? Let's see what I got wrong. What did I get wrong? Probably 0.878. Okay, let's look at the critical value and see what they got, because 0.878.
That's the 5.
Oh, their classes is 5. I'm sorry, I messed up. There's 5. Sorry, there's 5 classes. 1, 2, 3, 4, 5. So it'd be 0.878. So it'd be lower. I'm sorry. It's not greater. We got the not greater right, but 878. No linear. Well, I should have thought about that. There is no linear because it's what? It's almost like a horizontal what? It's almost like a horizontal line. So anything below 0.5, anything below 0.5, I think is what they call less likely to be a correlation. All right, next one. And that's going to take 2 or 3 more questions out. It's probably done logged me out anyway. Golly, what a surprise.
Because Russia's after you.
Is it?
We'll watch it after you.
It's not Russia now. It's, I'm not competent.
Listen,
I'm not competent to be a teacher. It's not Russia. I'm not competent. I need to be removed from this chair. Well, the 25th Amendment was actually written for JFK. Did y'all know that? Yep. Because when JFK got shot, a lot of people said, what would happen if he lived? And the 25th Amendment would be initiated to remove him from office and let LBJ take over. They almost did it for Dwight D. Eisenhower also, because he had so many strokes. But 99% of the time it's because somebody is physically physically not able. Yeah, physically disabled to run the office of president. It's not because you don't like the person. If you don't like the person, that's not grounds for 25th Amendment. Sorry. 19. That takes care of these. Ms. Welburn, Ms. Williams, and Mr. Goolsby, y'all good? Yes. 4.213. This is number 5. 4.213, number 5. All right, a student is in a junior college conducted a survey of 20 randomly selected full-time students to determine the relation between the number of hours video game playing each week, X, and grade point average, Y. She found that the linear relation exists. The least squares, the equation for the line is blah, 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 blah. Predict the grade point average of a student who plays 8 hours of video games per week. Student will live in a ditch and be a failure the rest of their life. Where is And don't give me this crap about ADD. Don't give me that. I got ADD. I can't spend 2.5 hours in a classroom, but I can spend 8 hours in front of the TV. That's bull crap. Okay, I'm finished. I'm finished venting. I've seen kids that, and my son's 10, okay, and he can do more than a lot of kids twice his age can do. All right, I'm not bragging on him because his head will get big and he can't walk through the door. But what I'm saying is, I know kids that are older than him. They're pathetic. And some of y'all girls know what I'm talking about. They are pathetic. They can't find their way out of a wet paper sack, much less change the tire. It's pathetic, and it's all because of those video games. And of course, their parents. The parents suck too. All right, I'm finished. So, what are you going to do? Well, first of all, you need to, you can plot it. You can plot points if you want to. It says, but they're not asking that. They're just saying 8 hours. So what are you going to do with 8 hours? Plug it in for X. So somebody do that for me. Let's take our handy dandy calculator. Okay, so whatever you say, Jack. All right, negative 0.0531. Yeah, I figured that would. 0.0531 times how many hours? 8 plus 2.9464. 2.9464. So he'll have a grade point average. It's not even a what? B? C average? 2.5. What did I do? What did I not? 2.5. It's supposed to be 2.5. Oh, 100. Oh, sorry. Sorry.
You just about had about 6 months left.
I know. For each additional hour that student spends video games in a week, the grade point average will fall. How do I know fall? Because the slope of the line is what? Let's put that in perspective. The negative slope means that it's going what? Down. So for each additional hour, boom, 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 what's going to happen? It's going to go down. By how much? 0.0531. 0.0531. If appropriate, interpret the y-intercept. Y-intercept is 2.9. That's when they hit what? When they hit 2.9 for y, that means that they're not playing any video games. They're getting at least a what? B average? Or whatever that's, whatever it says, average number of video games played, the grade point average of a student who's not played video games. There we go. This is a good test question, not because of the math, it's because of the content. I hate
just
to
a
say
good
it.
moral story thing.
I'm serious. I ain't kidding you. I've never seen young men that were so pitiful. Inept.
I'm saying that.
Well, yeah, you and I I was in the same business you're in. They can't do nothing. They can't do anything. A student who plays 7 hours per week has a grade point blah 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 blah. The student's grade point average is did we have up here? How many hours was this? 8. 7 had a grade point of 2.6 above. So, okay. So that's how you do that one. Let's go see if there's another one out there. We'll do another one since we did 2 like the other question. Let's see if we can do another one here. No, we don't have another one. Okay. Next one, 4.2, 21. 21/7. An engineer wants to determine how the weight of a gas-powered car affects the mileage. The accompanying data represents blah, 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 blah. All right, put that in your calculator. Find M and find B, or A and B. That's what they're going to ask you for, isn't it? Yeah, right there. It says round the X coefficient to 5 decimal places.
Who's that program they use for the calculator?
TI, it's a TI program. We buy licenses for it.
They got the calculator for it. You use that for everything.
You use a calculator for doing. No, you don't use a calculator very much except for the math plugging each other. Who is that? He has an extra calculator.
Yeah, I saw that. I was looking it up.
All right.
Yeah. What's that?
So stat, edit, 3726, 3883, 2704, 3548, 3249, 2974, 3816, 2567, 3571, 3834, and 3320. 18, 15, 26, 18, 20, 23, 17, 25, 20, 18, and 19. Go to your handy dandy stat, calculate, linear regression, second, L1, comma, second, L2, enter. There you go. We've got a negative slope. And it looks like you've got a 95% correlation. Negative. 95% correlation, which means, let's just plot it and see. Let's see what it looks like. Alright, second, there, and graph, and zoom. Nine. And there it is. So, take my handy dandy line maker. We're talking about a line that looks something like this right here. Now, if you wanted to draw that line, somebody tell me what did y'all write down the values that I had? Well, second function, stat. You got it? So go to y is equal and give me that point what? Negative what?
0.95.
Just give me 3 or 4 digits.
Okay. 95.
13x what? Minus or plus?
4a or b.
No, what is b? Is it positive or negative?
That's positive.
Okay, so plus what?
43.
Is it 43?
Yeah.
43.
And 7.
Give me 2 or 3 more digits. Is it just 43.7 or it's got any more digits?
I rounded it. 0.698.
0.698. And graph. I don't know why it's not graphing, but it should graph a line through there. Probably have to turn the stat off. Yeah. What?
Take the 9.5.
9.5?
Yeah, I didn't go on the
What is it?
0.0 or negative.
Negative
0.007.
7x? Yeah, that would make a difference.
Yeah, sorry, I gave you that.
Yeah, it's not going to do it because you got 2 different plots on. You got stat plot and you got the other one. It's not going to do both of them. All right, to do your stat plot, you hit second, y is equal, hit enter for 1, make sure this on, and hit graph. Now the reason it's doing that is because I'm trying to graph 2 lines at one time. So let me get out of this. That's how you do it.
You have a work
Let
email.
me take this out. There. There's the graph. Zoom 9. Well, I just put a line, but you're going to have to. It's not going to put the line in there because it's two separate animals. You can't put a line in a stat plot.
You can't do a stat plot and just a little line.
Yeah, you can't do that. Not with this one. You can with other calculators, but not with this one. All right, now it says find the least squares. So let me go back to the least squares. Stat, calculate, linear regression. There it is. All right, it says round the x coefficient to 5 decimal places. So that's 0.00, no. Round the constant to 2 decimal places. The constant is 0.01, negative 0.01. And the x is 5 decimal places, which would be 43.69809. 43.69809. I guess that's what they want. Oh,
Everybody's got them on south.
oh, did I not? Correct answer, 0.007. Is that what we got?
You got them back.
Oh. Oh, I'm sorry.
It's okay.
I'm sorry. I got it backwards. Don't get them backwards. I'll count them right. Sorry about that. Interpret the slope and the y-intercept. All right, let's go back and look at the slope and the y-intercept. Let's take the second stat plot graph. All right, look at that. Now let's say that this line that I'm drawing, it represents the line that we just calculated. All right, what can you tell me about that line? It's negative, and it's going to end up being up here. What's that first point? The first point in our stat plot. What was the first point? I can't find it right now.
3,706.
Okay, 3,018 gallons. It looks like to me that, let's see, 38. I don't see anything above 38 except for this one. So it looks like to me, if you look at the calculator, it looks like this is 37, 38. Looks like it's going to hit about 3,800 right in here. That's your y-intercept. Then down here, looks like it's going to hit something down here. I can't tell unless we extend it a little bit. A weightless car, which would be 0, will get what? 38 point, plug it in. We'll get 43.7 miles per gallon. 43.7 miles per gallon. Okay, that's not it. Interpret the slope and y-intercept if appropriate. Choose the correct answer for flow. Fix in the boxes. Well, if you plug in 0 for x, you get 43.7, so I don't know why that's wrong. For every pound added, will decrease 43.7. No, it will decrease 0.007. Okay. Will decrease by 0.007. A weightless car will get 43.7. They just combined the questions. That's all they did. The correct answer is B.
How about?
What did I miss? I thought I put that right here and here.
It says it's not appropriate to interpret the
Oh, that's, if it's not appropriate. Okay, it's not appropriate. Why? There's the y-intercept right there. Why? I guess, oh, I know. Is it reasonable for a car to be weightless?
No.
That's why.
No,
I wasn't thinking. In gravity, we have gravity here on Earth. A car cannot be weightless. The only person that's ever been weightless is Michael Jordan, right? Because he actually flies for a millisecond. I have to explain that to you in algebra and calculus. No, whenever somebody jumps, there's a point in space where you actually don't go up and you actually don't go down. It's a millisecond that you're actually flying because you don't go up and you don't go down. But it's a millisecond. Now, if you could change that millisecond into 5 or 6 minutes, then you'd be one of the richest men.
You're on to something.
Yeah, you're on to something. Okay, a certain gas-powered car weighs 3,600 pounds and gets 20 miles. That's about like my truck. Is the miles per gallon of this car above average or below average for cars of this weight? Well, let's see. 3,600 pounds would be what? Y. And 20 miles per gallon would be what? X. So plug and chug and see what you come up with. Okay, so that's backwards. Y is the gas mileage, sorry. And X is the pounds of the car, right? Yeah. So 36,000. So you punch it in.
Above.
It'd be above. Hold on. So 36 pounds would be negative 0.00704
To calculate.
multiplied by 3,600 plus 43.7. $18.35. So if it got 20 miles per gallon, it would be doing what? Be above the average. Would it be reasonable to use the least square regression line to predict the miles per gallon of a hybrid gas and electric car? Why or why not? I don't know how you could bring a hybrid into this because that's, I thought this
Not
was
using gas.
yeah. An engineer wants to determine of a gas-powered car. I would say no, because the hybrid is different from is a different type car. That would be my own. Okay, that's common sense. Just like common sense that you can't have a weightless car, but I didn't even think about that. All right. Is this a bad question? No, it's not a bad question. Just one you have to think about. Just remember, a car cannot be weightless. That's the only thing you have to remember. Next question. That's 21. This is 24. 24/8. Same type question. So here is the values. Now how many different, not count them up, but let's see, there's what, 9 to 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're comparing against 0.632. So write that down, 0.632. All right, get to work. I'm going to do this on spreadsheet, see if I can do it on spreadsheet. None Y's. Okay. That's what I didn't do right. There we go. None X's. There we go. Constant. Don't know the constant. What are you leaving for? Is it time to go? Oh, okay. All right. See ya. Well, I know what it looks like, but I don't know how to do linear regression. I'm still looking. Huh? I think I don't know if I ain't gonna worry about it. I'll just do it on the calculator. I'll have to play with it. So stat, edit, and that'll be 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Delete. And 89.7, 85.6, 82.6, 81.6, 78.4, 73.5, 64.1, 71.9, 65.1, and 65.8. Okay, for those that are listening, let's go ahead and go stat and go to calculate, go to linear regression, and second L1, comma, second L2. And write that information down. I don't know. I haven't never used it, so I don't know. 0.95 is your correlation coefficient, your X. I thought I saw that over here. There's the linear regression on your, will give you that. I'll have to find out how to find B, which is your 88.63. Okay, so write down that information. You know what the graph looks like. Now, what was the question asking? So take out your, that's going to be round to 3 decimal places. So that's going to be negative 2.845. negative 2.845. And then the other is 88.635. 88.635. Interpret the slope and the y-intercept if appropriate, blah, blah, blah. Well, I don't exactly understand what they're talking about here, but when I know it's a negative slope and it's going down at a 3 to 1, so that means 1, 2, 3, 1. So it's a pretty sharp what? It's a pretty sharp slope of 2.8 because that's almost 3 to 1. Everybody with me? So, and its y-intercept is 88. So it's going down pretty fast. It's dropping. The average final score, again, this is no classes, is blah, blah, blah. For the student that misses no classes, it comes out to be 88.6. All right, that's the student that misses no classes. But it says, I think it's going to be this one right here that says it's not appropriate. Because I guess they're thinking that not a lot of students can go a long time without missing classes. I don't know. Negative 2.845. Negative 2.845. Now this one's going to be the other one. Negative 2.845. The average final exam score is what? 88.63. I don't know if they want that rounded to the nearest. I'm just going to say 89. I have no idea what the answer is. Okay, they didn't put the negative on there. Okay. So the answer is B. I just put the negative on there. Now the reason this one is because do you have students that go to school and never miss a day? Yes. And those are usually the ones that you don't want. No, I ain't gonna say nothing. I remember I used to have a friend of mine that taught elementary school, and they said the ones that cause the most problems in school are the ones that show up every single day. They never miss a day. So now, compare a day, missing a day in school, missing no days in school, to a weightless car. A weightless car is not possible. Okay? I think, why don't they just say right here, it is possible for a student to not miss a day, or it is not possible for not, or it is not possible. Why do they, it is not appropriate to interpret the y-intercept? That sounds like you've done something illegal. I don't know. I guess I just teach different from other students. I mean, other teachers, I guess. Okay, predict the final score who misses 5 classes. So if somebody multiply 5 times 3 is negative 15. Negative 15 plus 88. 88 minus 15 is 73. I say around 73. What do y'all come up with? I estimated. I didn't do it in my head.
The y-intercept times 5 and subtract it from average.
You take negative 2.845 and multiply that by 5. You're plugging in 5 for x. I got 73. What'd y'all get? $74. Even. It says round 2 decimal places. Okay, I heard. That's what I heard. Enunciate and volume. Don't say, say 74.56. Whoever said, okay. Now I heard. Sound like you're giving out steam. What is it? 74.41. That is an acceptable answer. And look at there, you got it right. You feel good about yourself. Compute the residual.
Is that 2559? Like, I have 100. So they just make up stuff.
I have no idea what they're talking about.
Because the comments.
I think we should just get that.
Yeah, 2559 is the.
Where did you get 25.59?
We
Where did you get
subtract
that?
that from 100.
Why do you care?
I'm just guessing. This is pretty much I've done my whole
Oh,
life.
you haven't done it. I'm just going to put 3. See what it says. I have no idea. Somebody tell me what the residual is. I have no idea. They did.
If it's wrong, it gives you the definition.
Oh, I didn't know.
That was no plus.
0.91.
I wonder if you take. Let's see. No.
I'm trying to figure out what the residual
Can you
is.
do similar question and then do it again and do the definition?
I don't want to do similar question.
At this point, you just.
I'm just going to do you an example.
This is good enough. Just type it.
No, I don't know what the residual. I don't know, but that doesn't mean. It means that I don't understand what they're. Because they could call the thing residual and it be what's left over or something. I don't know. We have to. What is this? C?
It's like reading the book.
Predict the final exam. I did that. All right. What is the residual? Okay, I know what they're doing now.
That's that critical value.
Yeah, the critical value. What's the critical value that we started with at the beginning? 0.632 or something like that? What was it?
-0.94.
Okay, plug that in instead of the slope. I think that's what they're wanting me to do. Hold on.
I said it was ridiculous.
All right. Five class B's, we did that. Find the critical value. All right. We got this. That's the, if you look in your calculator, that's your correlation coefficient. This is the critical value. What are they doing with it? Compute the residual. Observe, predict, final. They're doing something different. No, it's 2.795. They're using the same. They're using the same equation, but they're doing something different.
this number.
They're leaving out a step or something. I don't. All right, look at this up here. Is this not 2.795 plus 89 point? Okay, is that the formula that's right here? Is that the same formula? Okay, well, that's what we used right there. 2.795 plus 89. It's the same formula. Then how are they getting two different? I'm trying to figure this out for you. Huh? Yeah, and that's what we did on. I mean, no, they plugged in 10. Say 10. My question is, where are they getting this 75.93? Why are they plugging in 5?
Because
How many classes were there? Yeah, it's 5.
In this one,
because it was 5 days. You're estimating
N is 10.
Reserve thing.
Yeah, there's 10. N is equal to 10. All right? They're saying 5 right here.
That's because they want you to estimate the GPA after this 5
Yeah,
days.
I understand that. But what my question is how are they getting 75.93 here? And where's the 79 point? I guess I'm just confused on what 75. I understand the point of the residual, the predicted value versus the actual value of the reserves. I understand that. But I'm not understanding where they got.
75.1.
Yeah, the 75.1, that must be what you get. That must be, okay, predict the final exam. That's when you do that right there, 74.1.
And that's the thing from the table.
All right, we'll go over residual Wednesday or whenever y'all come back, Monday or whatever. I'm not going to cover it right now. Because one class is over and I need to cover the residual.
Just don't put it on the text.
No, I got to do that because you're doing homework problems. So I'm not going to take them out because that's reinventing the wheel. So just let's finish it. Let's start. When day do y'all come back? Tuesday. We'll continue with residual on Tuesday, okay? See y'all later, guys.
So, yeah.